All right, so this is our final topic video for this lesson, and I know that we are totally maxing out our time here. In fact, chances are when I assign this, I will assign this over a couple of days, and hopefully you won't put it off and do it all at once because it is a lot of information. But I am going to try to keep this topic video really quick and short and to the point. The only reason I'm adding it in is because I think it's important to note that physics is not the only place where we use calculus. In fact, anywhere that something is changing, where there's like rates of change that have significance at each instantaneous point, so instantaneous rates of change, derivatives and calculus are going to be important. The example that we're talking about right now is in economics. So in the economics world, there are equations, right? We might have a cost equation, which let me write this down. So we have cost equations. Whoops, I need my pen. Okay, so we have cost equations, which we often call them like C of X. So it's cost in terms of X instead of like F of X, we use C of X. That really is cost, not cosine of t. As I'm looking at it, it looks a little bit like cosine of t. Cost equations, and we also have revenue equations. So that's cost is how much money we're putting out, and revenue is how much money we're bringing in. We usually call that R of X. Okay, I have an example here that I'm going to read to you related to this. But before we do that, you might be asking, okay, great, so there are equations, but what does that have to do with the rate of change? And that's a good question. In the economics business world, there's a term called marginal cost or marginal revenue, which refers to how the cost or the revenue is changing if we were to make, loosely speaking, because it's a little bit more exact than this, but loosely speaking, it's the cost of making one more. So if we're making 10, how much more is it going to cost if we decide we're going to make one more? Or how much more could I bring in if I decide that I'm going to create one more? And that kind of thinking is really important because we want to maximize our profit, right? We care about revenue and cost and how they balance out. We always want our revenue to be higher than our cost, and actually we want the discrepancy between revenue and cost to be as wide as possible. And so this idea of marginal or changing cost or changing revenue is important. So here is, let me just read this aloud to you. I'm not going to write it all out this time. If you want to follow along, it's on page 129 in your book. It's example 6, and it says, I'm just going to write out the key parts. So let me go here. I'm going to write out the equations as I read them. So it says, suppose that it costs C of X equals X cubed minus 6x squared plus 15x dollars. So this is a cost equation in terms of dollars, which we would expect, at least in the US, to produce X radiators. So I guess we're a radiator producing company. To produce X radiators when 8 to 10 radiators are being produced. So 8 to 10 is like the range, and when we're working within that range, it costs according to this equation. We plug in our values of X and we're going to get out a dollar amount. All right, but we have another equation. We have a revenue equation. And so it says that R of X, our revenue, is equal to X cubed minus 3x squared plus 12x dollars of revenue for selling X radiators. So this is kind of not just 8 to 10, but if we sell it, we're going to get in dollars the amount for plugging in whatever we sell for X. It says the marginal cost of, or actually find the marginal cost and find the marginal revenue. So what they're asking, remember, marginal in the business world is really just talking about, or in the economics, the language of economics, is how our cost or our revenue is changing if we were to add one more item. Like how much would it increase our cost and how much might it increase our revenue? The way that we do this is just to take the derivative. That's all we have to do. We don't have to do any of the complicated stuff that we did in the last one. Let me just erase these extra pieces here because I want to see. I want us to have a little bit of room. So it's saying find the marginal cost and the marginal revenue, and we're going to assume that we're producing about 10 right now. It's like in the 8 to 10 range. We're assuming that we're producing about 10. So we just take the derivative. So I need to add my eraser. That's not going to work. We want to find C prime of x, which all we have to do is use our rules of taking the derivative. So the derivative of x cubed is just 3x squared. The derivative of negative 6x squared is just negative 12x. And the derivative of 15x is just 15. And if we want to know what it is right at 10, we just plug in 10. So it would be 3 times 10 squared. So that would be like 300. So we're doing this at 10, right? Plugging in 10. 300 minus 12 times 10, so minus 120 plus 15. And we're going to get as an answer about $195. Let me do that in different colors so it stands out. It's going to be about $195. That is the approximate change in cost based on producing one more item when we're producing 10 already. So that's expensive, right? It's in the positive, it's not in the negative. We're not going to save money. It is going to cost us approximately $195 more to make that next one. But let's see what happens if we change the revenue, because that's important too. So in order to do that, we're saying, how would it change if we just produce maybe one more? So the rate of change is what we're looking for, in other words, the derivative. So let's find r prime. It'd be 3x squared for this first part. Then it would be minus 6x for the second term, and plus 12. And again, we're trying to figure it out at 10, so we're just plugging in 10. So we're finding r prime of 10. And that would be x squared. So 10 squared would be 100, times 3 would be 300, minus, it would be 60, right? 6 times 10 plus 12. And that is actually going to give us a change in revenue of $252. So to produce one more, it would cost us just shy of $200, but it would also bring in roughly $250 more here, $252. So in this case, if this is our business, we can use the idea of marginal cost, marginal profit, change in cost, change in profit, change in revenue, I should say. Not profit. Change in revenue. I don't want to get you confused with profit because we have to take in cost into effect. Marginal revenue, so change in revenue. We see that to add one more it would actually be in our favor. So if we had the resources, the money values add up in our favor. All right, that's all I'm going to say. I'm just going to stop it there because there's always more that we could talk about, but hopefully that gives you just enough of a picture of calculus in economics that we can come back to that in class. All right, good job finishing all this work. This was not an easy lesson, and again, I hope you did break it up over a longer period of time, and I will see you in class.